Good afternoon, everybody. My name is Darian Phillips, and I'm going to be talking about a project I call Mars Transit Direct. It's essentially the on-orbit assembly and refueling of a spaceship, pretty big spaceship. It's about 35,000 cubic feet total. So I'm going to talk about what NASA can do to assemble. Well, basically, the question everybody has been asking is, I guess when people saw the movie The Martian, they said, well, can NASA really fly a vehicle like this to Mars and back? Can it really be done, you know, in maybe the next 10 years by the end of the decade? And the answer is yes, it can be done. And the hardware is already available, and I'm going to show you. Okay, so first, to assemble the vehicle, you want to, I guess, we could start from forward to aft. So we'll start basically right here. This is the most forward part of the ship and the most aft part of the ship. Now, the real vehicle will be similar to this, but it will be slightly different. It won't have a spinning anti-gravity centrifuge. They'll just use work-on equipment. And it won't run on a nuclear ion electric engine. It will run on chemical engines. So I'll get to that. All right, so first let's start forward. So we have right here an idle port. This will be used launching a Galaxy spaceport, which is essentially this right here. This spaceport is available at Bigelow Aerospace. It just needs to be remodified. It's about 600 cubic feet in size, so it makes it a perfect idle port. It can dock perfectly with an idle port attached to it, and then dock perfectly to the International Space Station's Node 2 module. And next, we'll move to the tunnel right here. All that can be launched into orbit via the Starship, via the SpaceX Starship. Now, this cockpit right here that you see, it doesn't really need to be this big. It only needs to be about a third of the size of it, and then the rest of the cubic space can be used for a cockpit and lounge, which the ISS module makes perfect for. The real one that will be used on the Hermes ship will be about 5,000 to 6,000 cubic feet, as you can see here. Plenty of room for people to socialize, play games, you know, talk to friends and family. It'll be called Dynasty. It won't be called that. So I guess Dynasty Cockpit and Lounge. That's what it's called. Okay, so now let's move aft. This right here is where most of the communication equipment will be. So now we're moving aft, so now we're in between the communication antennas and the solar panels. So we're right in this section right here. And that's where the workout equipment will be. And that will be launched via Sundancer. It will be remodified for Mars missions. As you can see, it has a perfect spot for windows, great cupola style windows that are already on the ISS, so go perfectly right here. You could fit, I'm sure you could fit 2 T2s, 2 Cebuses, and 2 A-Reds in this ring, and then you have plenty. It's about 6,300 cubic feet total, and so you'll have plenty of room for, you know, exercising and for, you know, their fellow crewmates to move, you know, within the module, going from one place to another. Okay, so we're going to, got the solar panels right here. Those will be the same as what's on the ISS. They'll be redesigned for Mars, but, you know, the technology, hardware, and all that is the same. Since this vehicle we built using mostly the same routes that the International Space Station was built with 1980s technology. So we're moving aft again, and now we're in this section right here, and this is where the cafeteria will be. And the NASA Transat module makes a perfect cafeteria. As you can see down here, you got plenty of room for eating. They got their own, you know, personal table. You got windows right here. As you can see, there's 3 levels. So in the middle level here could be where the food will be prepped. We've already seen plenty of, you know, videos and pictures of the NASA food equipment for warming the food, you know, the dehydrated food. And the 3rd level up here will make a perfect solar storm shelter. It takes about 5 inches to shield us from solar flares. The cosmic rays, there's no shielding from that. But the solar flares will be perfectly surrounded by 5 inches of water. You can surround this whole section with 5 inches of water perfectly, and you still have room for plenty of astronauts to move around. Okay, so we're now going to move aft again, and we're now in this circular centrifuge. Now it will be slightly different from this. It won't be spinning, but this truss structure will be perfect. Now it will be a V-shaped truss structure just like this right here. So, and the interior-wise, I'm sure everybody has seen the interior pictures of the ISS. Just picture the Russian segment. I think it's a Zvezda, but it's really tight, but there's room for about maybe 1 or 2 individuals to fit through. So just picture the interior size-wise of that. That's how much room you have to move about the truss where the 5 Bigelow personal crew staterooms will be, and that's what you see right here. So this will make a perfect crew quarter. There's plenty of room for sleeping bags, personal photos, whatever an astronaut will have in their personal crew quarter while they're spending their time in space. We're now going to move aft one more section. In this section right in here, this makes a perfect place for a bathroom. And the Bigelow B330 makes perfect. There it is. You see, there's plenty of room for a bathroom. This is about 12. Oh, and I forgot to mention. Sorry, forgot to mention. Remember where the Sun Dancer was? Right there. Okay. This one is about the Sun Dancer habitat is about 6,300 cubic feet. And I forgot to mention cubic feet. I'm sorry, to give you guys an idea of how big it is. This section right here where the cafeteria was, the trench tab is about 11,000. So this module right here, section, 11,000 cubic feet total. And, we now moved into the, now there'll be 5 beam modules hoisted on this whole circular structure right here, just like that. And each one of those is approximately 565 cubic feet, as you see this section right here. We are now in this section right here, where the bathroom will be, which is about 12,000 cubic feet. And to give you an interior of what this looks like, as you can see, you can fit probably 2 toilets, 2 bathrooms, and 2 showers. That would be very nice on the Mars mission, having nice showers. Plenty of room for that. Okay, let's move aft again. We're going to move now into, okay, so we're now in this section right here. This will make a perfect science lab, and the Genesis spacecraft makes perfect for that. They're about, I think they're about 800 cubic feet. And so you can have science racks in this section right here. And you could probably have another science rack on this section right here, so when the Mars astronauts come back from Mars, they'll be able to analyze the rocks and everything. Now on the other side of the ship, it'll be the same thing, but this side will be a storage room. And it's where the astronauts will store their spare helmets, backpacks, right here. They will store EVA suits, probably one. About 2 or 3 EVA suits, I'm sure. That would be real nice to have. They're going to have to do EVA because they're going to need to refill the supply mods when they come back up from the service. Okay, so let's see here. We're now in these 2 sections right here. Okay, on one side, the science rack will be on this side. So you're going to have right here your landing equipment for the Mars mission. The Dragon 2 capsule makes a perfect Mars lander. I was wondering how well it would do on a full Mars landing. It was actually canceled by Musk in 2017, but I believe it could do the job. One of the reasons is it can land on parachutes. So I guess you deorbit, you do a full re-entry on Mars, and as you get down to the surface, you apply the retro rockets, the Dracos, and now you could probably, I'm not sure how much fuel is in that actual Red Dragon for a complete full thrust landing, but if you apply it with parachutes, it could do the job. So you no? Well, then you could probably let the parachutes, and then so the rockets will have to do it the whole way down. Okay. So we'll let the Draco thrusters do the landing all the way down to the surface, and that's how it would be. So on the other side, you're going to have the storage room, and that's where, again, the trash, spare aviations, all that stuff. You're going to have an extra Mars ascent vehicle right here. Robert Zucker in the ERV makes a perfect Mars ascent vehicle, or NASA could design one. That'll be fine. They already got plans for it. But since the ERV has already been designed by Mars Direct, it'll make a perfect ERV, since you could leave the second stage on and use the fuel tanks for the orbital maneuvering systems that will be needed for attitude control on the return trip. Same thing with the Red Dragon. You do the orbital moving rockets on the Red Dragon and use that for attitude control for the whole ship. It'll be tethered, and it'll extend, the supply mod will extend up and down the length of the ship, starting from fore to aft, and then from aft to...
Too close for it, it's over Mars.
That's fine. And then from aft to the center where the... And solar panels, solar radiators, that'll be all the same. And we're now moving aft again, section right here. This will be where the fuel tanks will be stored. With a special thanks to Max for giving me some help on the fuel calculations. Here's a typical Boeing external fuel tank. Those will be perfectly, you can fit them perfectly on the ship. They could be launched and then attached via the ship. NASA's been using external fuel tanks on the shuttle for 4 decades. So no reason why I won't work on a spaceship. They'll just have to be modified for Mars. You could also stack them side by side for room, and then rotate them about a fixed axis, just like how the space station's solar panel trusses are rotated about axes. That's how that would go. For power, 7 Raptor SpaceX engines do the job, producing about 3 million pounds of thrust. And once again, I would like to thank Max for the fuel calculations. He helped me out a lot with that. Come to find out, I was off by a factor of 6. I thought at most it would weigh about I thought the wet weight of this vehicle would be at most 9 million, but it actually comes out to be 18 million. But we're still in the ballpark. We can still assemble this vehicle, even with 18 million, because the BFR has just been upgraded to 330,000 pounds to Leo. 3 launches times 4 is 12. 12 launches, which means if you launched it once a month, you could deliver 1 million pounds. That was 3 launches, 1 million pounds times 12. 12 million. No, correction. 330,000 pounds times 3 launches would be, that's 1 million pounds per 3 launches. So it would be a year, 4 million pounds. Now, the crew can only fly to Mars every 4 years with this vehicle. But if you send up the fuel unmanned, that means for 4 years straight, you could deliver about 4 times 4 is 16. You could deliver about 16 million. If you really try to, get those launches in there, that's 18 million pounds, which in 4 years, you got time. So we're still in the ballpark. We can still do it. Now, the hydrogen, since we don't have to worry too much about the boil off, those could be launched on unmanned ships, in orbit, in Leo, and then we launched the crews with the oxygen so we could minimize the boil off as much as possible. So the combination with that, plus the Shiver thermal program that's being worked on by NASA right now, we might be able to pull this off. And you have the vehicle with the fuel and everything. And that's Mars Transit Direct. I'm trying to make sure I got everything. That's pretty much it. Oh, the refueling, yeah. It could use the BFR Raptor, 7 Raptor engines or whatever. Well, actually, it could use 7 VFR Raptor engines in a block of the Starship formation. So it's actually filled via butt-to-butt with Starship. So if the Starship's block is used on your engine mount right here, then you would pull the BFR engine butt up to the Hermes BFR engine butt, and that's how the ship would be refueled. It would have to be done continuously. Now the fuel that will be sent up on the unmanned ships, on the unmanned pods, those could actually be sent fueled, and those could be done side by side, because I guess Musk has two ways of refueling the VFR, butt to butt and side by side. So either way will work. Either way will work. And the engines could also be changed via EVA. You could split the 7 Raptor engine block in half and fit it in the carway of the VFR. Correction, Starship. Sorry, Starship. And so that's how that would work. I think I pretty much covered everything. I'm trying to remember, is there anything else? I think that's pretty much it. Remember, it'll be docked and flown to the ISS's Node 2. A mission, pretty good. It should be done on about 2 test flights before the mission actually goes to Mars. You would definitely want to do that. So I thought, well, hey, why don't we do a test flight around Venus? You know, maybe we can do a Venus flyby. I said, no. What about maybe a Venus and a Mercury flyby? You see, the conjunction with Venus is only about 1.5 years. But then I thought, well, if we do a Venus and Mercury flyby, that will work. And I thought maybe we could fly to an asteroid for a test flight mission. That would be perfect. You know, and then after that, the first mission would be to fly this thing to the ISS. How about that? That'd be sweet, huh? Yeah. And then on, I guess, the third mission before the end of the decade, you fly to Mars and back. And the HAB and rover will be already on the surface, waiting for the astronauts. And I think it might be a good time to do questions now. I think I pretty much covered everything. Thanks. Questions, please. Yes.
We're going to try and fuel this thing in LEO.
Yes.
With shipments from the ground.
Yes.
Have we got any experience with transferring like liquid oxygen?
Oh, they're already practicing transferring fuel right now on the ISS, on the space station. They've already got astronauts up there.
Not cryogenic propellants.
Yeah, they tend to use unconventional dimethylhydrazine and nitrogen tetroxide. So anyway, that's it, on the to-do list.
Yeah, but they are working on transferring fuels right now. Satellites, yes.
Absolutely.
Not cryogenic propellants. We have never done on orbit mass cryogenic propellant transfer.
Right, they're still working on that, I mean.
But there are technical difficulties, but there's no showstoppers.
No.
Yeah, I meant they're working on it. They're learning.
Yeah.
Go ahead.
So, may I ask why you picked a fictional spacecraft as your starting point, instead of starting from scratch and designing a spacecraft to do this?
Well, this just gives them, this would give them an idea of what the ship would be like, because the real ship would be very similar to this, almost exact.
Not really. This spacecraft was designed by Andy Weir to be a low-thrust solar electric propulsion vehicle. You're talking about a chemical propulsion vehicle that needs to take, a third of a G of acceleration with its engines burning. This structure is going to fall apart if you try to burn it with a chemical engine at a third of a G. So while you may have all the components in place, I strongly recommend starting from scratch and designing your own vehicle instead of taking an architecture that was designed for an entirely different purpose by a computer graphics artist who may or may not know anything about aerospace engineering, and design your own vehicle.
Well, it was actually, it looks very similar to the ISS. Any vehicle that would be assembled on orbit, it will have to look like this if you want to assemble it on orbit. There's no way you could launch a vehicle from the surface of the Earth straight to Mars that big.
You can do on-orbit assembly, though.
Yeah, on-orbit assembly.
For chemical interplanetary vehicles. I'm just saying this is not it. The ISS, this design, these are designed for a very specific purpose, and that purpose is not interplanetary chemical propulsion. So I suggest design your own spacecraft. I would love to see I would love to see your own take on how this vehicle would be designed. Don't start with a fictional portrayal, solar electric propulsion spacecraft.
You don't think it'll look like this at all? You know?
Not if it has to accelerate with 7 Raptor engines behind it. That structure is going to fall apart.
I think what he's saying is if you take a bunch of motorhomes and you tie them all together and then try to force them down the freeway, you're gonna have a yard sale of motorhomes along the freeway.
Well, I guess reinforcement will be.
There's a reason when the ISS reboosts, there's a reason it only accelerates at a couple of milli-Gs instead of 300, instead of 0.3 Gs.
Right. Well, they're going to use consistent reinforcement, no doubt. Yeah. Any vehicle that's going to be assembled in orbit will need consistent reinforcement. So, yeah, absolutely. Yeah. Next.
Have you considered a ring of tanker starships with fuel transferred both side by side around the ring and to the main spacecraft? And do you think this would be possible?
Okay. Repeat that one more time.
A ring of tanker starships, so they connect side by side,
Yeah.
but also with their bellies toward the main spacecraft. And in this way, they share fuel for their engines and for that spacecraft.
Yeah, we were going to send up unmanned fuel pods, and it could be refilled either side by side, like what you just said, or butt to butt.
But
They will be on rings, the unmanned ones, of course, because we're going to send them up on pods. So they probably would be in similar ring-shaped fashion, just like how Musk just launched the Starlink satellite. So it'll be looking similar to the Starlink, but they'll be filled with pods. And the astronauts would probably refuel it that way, doing EVA in low Earth orbit. So you pull the pods up, you pull the pods in a Starlink fashion, just like Musk, and you pull it up next to the fuel tanks, and the astronauts could actually, connect hoses via EVA and refuel it just like that. So, yeah. Did I answer your question?
sort of, yes.
Okay, thanks. Next. I love these questions. They're great. My goodness. Any more? Come on. Come on. Yeah.
If we just focus just on the, you're using some of the Bigelow kind of inflatable.
Yes, inflatable.
If we just take what we have now up in orbit,
These have already been
these have
designed. Yeah, the Sundancer, the Transhab, the Genesis.
I see what you mean.
They've already been built.
You're using everything that's already been tested.
Yeah, they have. It's not that they've been designed already. They've already been built. They just need to be launched. It's great. It's unbelievable. I couldn't even believe it myself. I thought we were having to design everything new, but I was just doing some research and
it holds there and
everything. And the structures are just as strong as concrete. They said. Can you believe that? An inflatable structure is just as strong as concrete. They said it supports, it protects from radiation and micrometer. It's even better than rigid structures that are on the ISS. Unbelievable. Any more questions? Well, let's see here. It's about 20 after. I still got another 10 minutes. So let me think of, is there anything else on here that I didn't cover? If you were worried about how on God's green earth you would control the attitude of a vehicle this size, let me talk about that since I have some more time, because that's the one thing now in the movie they use the movie ship, they use thrusters on the front of the ship. Now, somebody might say, well, you could still even control attitude just from the ship, putting thrusters on the side. But since 3D printed technology is still so new, it probably wouldn't be a good idea to send that technology to Mars. So the best thing to do would put it on orbital maneuvering pods of the supply ships and apply a tether system and let the tethers run up and down the whole length of the ship. And you could also... aside from the 7 Raptor engines that'll be on the back of the ship for the propulsive orbital insertion and orbital injection maneuvers, you will have about 2 Merlin engines on the side. That could be used for orbital maneuvering. not necessarily leaving the escape velocity of the Earth, but just to, you know, boost your orbit up when you're ready to dock to the ISS. And that's how that'll go. I think that's pretty much it. Oh yeah. And there you see the butt of the Starship, how it will dock with the, you know, it'll mate with the butt of the Hermes engine. So yeah, that's the ship we're in. That's it. Okay. Any more questions?